Okay, so now we'll move to the next integration question, June 2018, question number 9. So they say here, find the integration of 1 over 2x minus 1 square dx. Okay, how do you do the integration of 1 over 2x minus 1 square? So basically what we use here is I have written here, these are my general rules I use for integration. You learn these rules in P3. So rule number 1, because you can see 2x minus 1, even though it's in the denominator, you have a power. So when you have a power, we work with this first rule, not the third one. Okay, we can't go with the ln rule. You'll have to go with the first rule. So first you have to bring 2x minus 1 to the power 2. You have to bring it to the numerator. So let's bring it to the numerator. What do I get here? This is part A, 1 over 2x minus 1 square. So when I integrate, I get here 2x minus 1 to the power minus 2. 2x minus 1 to the power minus 2. Now let's use the rules of integration. 1 over A. So you have to divide with your x coefficient. So the x coefficient here is 2. So 1 over 2, as you can see in the rule here, 1 over A, ax plus b to the power n plus 1 over n plus 1. So 2x minus 1 to the power n plus 1. Minus 2 plus 1 is minus 1. Divide by minus 1 plus c. So you end up getting minus half times 2x minus 1 to the power minus 1 plus c. Do you agree? So do they ask us in any format? No, they just ask you to get the answer. So minus 1 over 2 times 2x minus 1 plus c. Do you agree? I just brought the 2x minus 1 to the power minus 1 down as a division. I mean, I just brought it down because of the power minus 1. Okay. Okay, then we'll go to the next part. Okay, so part B. Moving on to part B. They say here the finite region R shown shaded in figure 2 is bounded by the line with equation x equal 1, the curve with equation y equal fx, and the line with equation y equal 4 over 3. So I think, I have read this part, right? Figure 2 shows a sketch of the curve with equation y equal fx, where fx is 12 over 2x minus 1 and x is greater than or equal 1, less than or equal 5. Basically, they've sketched the fx curve between 1 and 5. Are you with me? And they say the finite region R shown shaded in figure 2 is bounded by the line with equation x equal 1 and the line with equation y equal 4 over 3. Yeah. The region R is rotated through 2 pi radian above the x-axis to form a solid of revolution. Okay, so here we are going to work with solid of revolution. So when it comes to solid of revolution, you need to remember the equations that you need to work with here. So in solid of revolution, you get the equation in 2 sections for parametric and for Cartesian. So parametric Cartesian volume of revolution is volume equal pi y square dx. And the parametric volume of revolution is the volume equals pi y square dx by dt with respect to t. Okay. Y square dx by dt. This is the parametric equation. And this is the Cartesian equation. So we will go with Cartesian here. Okay, so we will go with the Cartesian equation. Okay. Okay, so then in this case, you can see I have a Cartesian equation because your y equation is in terms of x. Okay. Right. So then let's go for the volume of revolution. So by the way, when you do volume of revolution, you know, in volume of revolution, you take your curve. So the fx curve is this one. Remember, this is your fx curve. So when you rotate, you now in volume of revolution, basically what we do is we take this curve and rotate it 360 degrees around the x-axis. Or we rotate it 2 pi radians around the x-axis. Basically, you end up creating a 3D solid object. Okay, so when you rotate 360 degrees around the x-axis, you end up creating a solid 3D object. So and basically, always remember to, I mean, just to see now how it works here. The two open ends here, these two ends here will become the two circular faces. So basically, what the easiest way to construct this is You keep the same distance over to the other side and you draw a circular face. So this is the circular face here. Over here, keep the same distance, the same kind of gap over here. Okay, keep the same amount of gap and then draw another circular face at this corner. This is how we create the 3D object. Can you see? So at this end, I kept the same space over here and I created like a circular face here. And this one is another circular face. And now draw the exact, how do we say, the reflection of this on the other side. So over here, you can see I'm drawing kind of like the exact reflection. Can you see? And then they want this line, the cutoff line to be y equal 4/3, which means the cutoff line here will be y equal minus 4/3. Can you see? So this point here. And you can see that this is another circular face here. So remember when you use volume now, can you see the 3D object that you have created? So you can see in this 3D object, they actually want the area, the volume that you get through this shaded part. They only want the volume created by the shaded part. So you can see here the shaded part is over here, right? It's about the line y equal 4/3, which means when you rotate the 360 degree around the x-axis, the shaded part will come below the line y equal 4/3. So basically this area. This is not this area, the volume. Can you see? So you need to find the volume of the entire 3D object, but I think you can see in the middle, you end up creating a cylinder. That this y equal 4/3 line, when you rotate, you end up creating a cylinder. So basically, remember when you use volume equal pi y square dx, okay? Now here the y value is this fx curve. So when you use this equation, you will get the volume of this entire solid. The full solid, you will get the volume of this full solid, including the cylinder. And then since you do not want the cylindrical part, you get the volume of the full 3D object and then you remove the cylinder. Okay, are you with me? So first what I'll do here is I'll get the volume of the complete 3D object here. Okay. Okay, so then the next part, so we'll get the volume of the complete object. Volume equals pi integration y square. So here our y equation is the fx. So that's 12/2x minus 1. So this is y square. Y square in the sense you use directly the square of 12/2x minus 1 pi y square dx. Pi y square dx. Do you agree? So I'm using the Cartesian equation here. Okay, so volume is pi y square dx. So let's work on this now. Pi, so integration, this is 12 square 144 over 2x minus 1 square dx. So the 144 is a constant. You can take it out. 144 pi integration of 1/2x minus 1 square with respect to x. By the way, what are our limits? The limits start at 1, end at 5. Can you see? Your limits start at 1, end at 5. Okay, so now how do we do this integration? So always when you're doing these kinds of questions, keep an eye on the parts that you did in the earlier part you did. So for example, you can see in part A. Now we are not going to go and integrate this all over again because we have done the integration in part A. As you can see, integration of 1/2x minus 1 square is already done here. We have the integration. So just substitute this value and input the limits. Okay, substitute value. So here integration of 1/2x minus 1 square is minus 1/2 2x minus 1. So here volume equals 144 pi minus 1/2 2x minus 1. Right, no need to put the plus c because we are going to apply the limits. Minus 1/2 2x minus 1. Limits are from 1 to 5. So volume equals 144 pi. Let's input the limits. 5. 2 times 2 into 5 is 10 minus 1. Subtracting with the next one, minus 1/2 times 2 into 1 is 2 minus 1. Do you agree with what I did here? I replace first the x value with 5, then in the middle you put compulsory minus, and then you replace the x value with -1. And now simplify and get the answer. How much do we get here? 144 pi times minus 1 over 2 times 9 here, which is minus 1 over 18. This is plus 1 over 2 into 1 is 2. How much is the answer? Minus 1 over 18 plus half is minus 1 over 18 plus half is 4 over 9. So 4 over 9 multiplied by 144, you get 64. So basically 64, don't forget the pi. 144 into 4 over 9 is 64. And then do not forget the pi. So volume 64 pi. This is the volume of this entire large object. Okay, so when you rotate it, the volume of this complete object is 144 pi. Then what you do is you need to remove this cylinder. Okay, so you need to remove the cylinder. So basically for cylinder, you don't need to go with pi y square dx, because for the cylinder, of course, the graph, I mean, you can see here, it's the line y equal 4 over 3 that is rotated to create the cylinder. Basically, what you could do here is you could go for the volume of a cylinder directly by using pi r square h, right? Volume of a cylinder. Volume of cylinder is pi r square h. Are you with me? What is the radius of this cylinder, by the way? What is the radius of the cylinder? How much is this radius? So here the radius is the y value, isn't it? Y value 4 over 3 is this distance, this small distance here. So radius is 4 over 3. So it's radius square into height. So height is the this height of the cylinder. Can you see? So by height, this is the height of the cylinder. So what is the height of the cylinder? Starts at 1, ends at 5. So height is 5 minus 1. Height is 4. Okay, height is 4. Okay, let's simplify. What is the answer here? Pi into 4 over 3 square into 4. So pi into 4 is 16 over 9 into 4. So I get 64 over 9 pi. This is the volume of cylinder. And then the volume of solid. How do I get the volume of the solid? The volume of the solid that is generated, basically the volume of this section without the cylinder. So how do we get that? Volume of solid is the volume of the entire total thing, 64 pi. You subtract with 64 over 9 pi, isn't it? So 64 minus 64 over 9. 64 minus 64 over 9, it's 512 over 9. And then you can just put the pi. Now you don't need to type the pi in the calculator. You could type the pi in the calc, or else you could, since pi is common to both the terms, you could just type 64 minus 64 over 9 and get the answer as 512 over 9 and then the pi. They're asking the exact value. This is the exact value. So in terms of pi, definitely give your answer in terms of pi, because they want the exact value. Okay, so this is the exact value. This is the answer. Okay.